Hi all, today we're going to talk about doing packet tracer in the Cisco ASA and PICs. The point of the packet tracer is to trace the flows that a packet would take as it traverses the firewall and to see the rules that it would match and if any of those rules would be drop rules, so something that would impede the packet from getting through the firewall. Conversely, as it will also show you all the rules that allow, you could also use it just to get an understanding of the flows that happen in the firewall. But for troubleshooting wise, generally speaking, I use it mostly when there's a problem with packets getting through the firewall, and you could use it maybe in conjunction with packet capture that we talked about in the previous lab. If you haven't seen that one yet, have a look. It's a good tool, and this is also another. So we'll get to it. The syntax is packet-tracer, and then input, and then the interface on which the packet enters the firewall. So we're going to talk about, first we're going to trace what would happen for pub 1 to get into DMZ server 1 on port 80, because we're hosting a web server there. So packet-tracer input outside where the packet enters the firewall. The protocol, TCP, your source IP, and we're talking about pub 1, so he's .10. His source port, if you don't know what the port is, put anything in there. If you do know what the port is, the source port, go ahead and put the source port. Then your destination. I have a static NAT for DMZ server 1. He NATs to 100, 100, 100.10 on the outside. So we'll go ahead and put that in there. And then port 80. And if you hit enter, you get the results. So phase 1 is a flow lookup. There's no matching flow, so it's going to create a new one. So allow that, create a new flow. Phase 2 is a NAT. We've got an unnat. There's a static, and the action is allow for this. So what it's saying is, again, our .10 on the outside is natting to our DMZ server 1 host on the 2020 subnet.10. And he's telling you here, so it's a DMZ host, again, 2020-2010. From outside, anyone can get in there. It's a static NAT translation to 11100.10, like we said, and it's going to divert that to the egress interface. It's going to exit interface DMZ, and that's correct for us, right? Our 2020 subnet is on the DMZ. Phase 3 access list log allow. So it's saying that we've matched access group outside ACL, which is bound inbound on interface outside, and the element that matched in there is a permit TCP from anyone to host the .10 on the outside equal to port 80. IP options, phase 4 is allow. Phase 5, it's doing the reverse path forwarding check, and it's allow, permit. 6, it sees the NAT again. It's seeing again that same static NAT. And then phase 7, IP options allow. Phase 8, flow creations, given it a NAT ID 21. Phase 9 is a route lookup. It's seeing the next hop is the box because it's directly connected to this interface, and it'll actually show you the MAC address. So the next hop is actually because you're ARPing, right? Once you're on the same subnet, you're not routing by IP, you're routing by MAC address. So he's ARPed and found this MAC address for our DMZ server 1 and allowed it in. And then down here is just a summary of everything. So the result is your packet source is coming on the outside interface, and the interface is up and up. Packet destination for the DMZ interface is up and up, and the action is allow. So good. Let's have a look at what would happen if we came in on SSL from pub 1 into DMZ server 1's public IP, which again is 11100.10, but we came in on port 443. So our flow lookup, there is no matching flow. Create a new flow, allow it, create a new flow for it though. Phase 2 is again looking at for the NAT. It's denatting, right? Because again, you're hitting the public, you're being natted to the private, and again, it's going to send you out the interface DMZ where it's connected. So that's good. That's allow. Uh-oh, look at that. Phase 3 access list. We've got a drop as a result on the access list. And again, it's seen that you're matching an element in the outside ACL, which is bound to the outside interface inbound. And the element you matched was deny IP any. Because I actually only have 2 elements in this access list right now. It's to permit anyone to get into DMZ server 1 on 80, and then a deny IP any to log against it. If I didn't have the rule there, the implicit deny you'd still match here. It would say, there'd be a match on phase 3 access list. The action would be dropped, but it would just say denied by implicit rule, right? But I actually have the rule in there for logging. If you haven't seen the access list lab yet, have a look at that, and we talk about why you might want to put the deny in there as opposed to just leaving the implicit. So I have it there, and it tells us we hit that element. And again, the summary down below, the results coming inbound on the outside interface. The interface is up and up. Going to go out the DMZ interface, which is up and up, but the action is drop. And it gives you a drop reason down here. Flow is denied by a configure rule. If you just go up, because you could start out by just going right to the bottom, looking at the result. Did I pass everything? Okay, fine. I'm good with that. I don't need to look at the rest of the flow. But if you want to see, oh look, I got a drop. Let's find it. Just scroll up until you see the result for drop, and there you go. For us, it's the ACL. Let's say we wanted to make sure that PC1 could browse out to Pub1. Maybe he's having a problem. What's going on? He gives a call. I think maybe having issues. Maybe it's the firewall. Can you have a look? Sure, we can. We can do a packet tracer input, and the source now is the inside interface. Protocol's TCP. Our source is 10.10.10.10. We don't know the source port, so we'll just plug in anything. His destination IP is Pub1, and he's trying to hit port 80. We hit enter. Phase 1 is allow. It's going to create a new flow though, because there's no matching flow. Phase 2 is a route lookup, and the result is allow. It's found the default route pointing to the outside interface, so that's where it's going to go. IP options for 3 is allow. For 4 we have a NAT check, and there's a drop. So it's saying there's a NAT inside 1 anyone. NAT control is enabled on the box, so you need NATs as opposed to no NAT control. We do have a NAT statement. However, dynamic translation to pool 1, because we had a NAT1 ID, there should be a global 1, no matching global. And again, if you just scroll all the way down, there's the results. You're coming in the inside interface, which is up and up, going to exit the outside interface, which is up and up, but the action is drop, and the drop reason, flow is denied by a configured rule. The rule is we're missing a global statement. So it's good because it's very specific, right? Sometimes it can be a little confusing to read, but most of the time, the results you get back for the reason you get back for the drop is fairly clear. And again, if we do a show run NAT, we have a NAT inside 1 everyone, show run global. Oh, look at that, he's correct, we don't have a global. So if we do a global outside outside 1, sorry, interface, now we've added the outside interface to the pat pool. And if we do the packet tracer again, we'll just go all the way down to the bottom. Again, the inside interface source up and up, outside up and up, and the action is allow. And if we just scroll back a little bit, we'll try and find the NAT that it matched. There you go. So phase 5 was the NAT match. NAT inside 1 anybody. NAT control is enabled, so we need a matching global as well. And it's telling you there. Dynamic translation to pool 1, so it means there's a global 1. It's padding to the interface IP, and there's the IP we're going to match. So again, it's just another tool for your troubleshooting toolkit. Good to have. You may want to use this in conjunction with a packet capture that we talked about in the previous lab. Yeah, I should probably mention, you can put detail in here. If you didn't quite get enough information, you can put the detailed keyword on the end of your packet tracer command, and it will give you a bit more info. You can see here we've got, let's see, here. We've got the phase 7 in this flow, the flow creation. It's giving us, translate adjacency. It's giving us a little more info. Module information for reverse flow. So on and so forth. So you can get a little more info by putting the keyword detailed on the end. But try it out, play with it, packet tracer. You don't have to do a no after you apply the packet tracer. It doesn't actually, enter it into the config. It just runs your command against the current elements and gives you the result. So you don't have to worry about removing it in the end. It's not resource intensive on the device, and you don't have to have. The nice thing about it is it's not like having the packet capture where you need someone to create the traffic and capture against it. In here you can just run the packet tracer. It'll tell you what the expected outcome is, even if no one's trying it, right? So you're simulating what the firewall is going to do against the flow, even though it's not happening. So good tool, try it out, play with it. Any questions or comments, please leave them on YouTube and I'll do my best to get back to you. Thanks for watching.